In this exercise, we are going to be applying derivatives to economics, in particular to cost functions, as well as revenues and profit. But before we tackle this exercise, we're going to highlight a little the difference between the different cost functions, which are the total cost, the average cost, and the marginal cost. So if we were to start by considering that you own a factory that produces a certain number of items, now the total cost of production of these items is, in general, the sum of the fixed costs and the variable costs. The fixed costs, which usually represent the amount of money you'd pay before producing any items, which could include the salaries of your workers, or perhaps the rent of the factory you're using. However, the variable costs are the costs that do vary while the production is happening, which it could be the electricity bill, because the more you use electricity in order to produce, so the longer you're producing, the more electricity you're consuming, your electricity bill will be larger. And it could also be the cost of the material that you're using. The more you produce, the more material you'll be using. So, however, the fixed cost and the variable cost altogether, they represent the total cost of production of a certain number of items. So over here, the total cost could be studied or given on weekly basis, on monthly basis, or on yearly basis. It really depends on the context of the exercise. However, if the total cost, for example, is represented by a function c of x, so that is the total cost of producing x items. So for a given x, c of x would be the cost of producing x items. Now, if I've already produced x items and I know that the amount of money I have to pay, which is the cost of producing them, is c of x, then in order to determine in average how much did I pay to produce a single item, so that would be the average cost, which is determined by considering the total cost and divided by the total number of items produced. So c of x over x would in fact give me the cost per item, and that of course is given that you have already produced x items. So having already produced x items, in order to determine in average how much did the production of a single item cost, I would consider the total cost and divide it by the total number of items produced. However, when it comes to the marginal cost, now the marginal cost is the cost of producing an extra unit given that I have already produced x units, for example. So if I have already produced x units and I know that these x units did cost me c of x, that's the amount of money I paid to produce x units. So how much would I really pay if I were to produce an extra unit? So over here, if I consider this to be the cost of producing x plus 1 unit, the marginal cost is in fact this difference. So this is the marginal cost, which I'm going to represent by c of x. So the marginal cost would basically give me the cost of producing an extra unit. So it's the change in cost when an extra unit is produced. Now, this is completely different than the average cost. For the average cost, you would have produced X items, and you would be determining how much did the production of each item cost you in average. However, now that you have produced X items, you'd wish to determine if producing an extra item, how would the cost vary by that production, by the production of that single item. It's like studying the change of cost at the margin. At the margin. This is why it's called a marginal cost. Now, so basically the marginal cost is in fact the difference between the cost of producing X plus 1 items and the cost of producing X items. Now, why are marginal costs important to study? Because, for example, if I have produced X items, I know that in average each item, for example, cost me $6 to produce. So if my selling price of that single item is $10, so if I were to start selling after producing X items, then I would in average have a profit of $4 by selling each item for $10. However, by determining the marginal cost, so I have already X items produced, I need to check if producing a single item would still in fact give me some profit. So if the marginal cost of producing that extra item would give me, for example, a cost of $7 to produce that extra item, then in that case I know I'm still below my selling price, so producing that extra item would still give me profit, so I would proceed with the production. However, if producing that extra item did give me a cost of, for example, $12, then in that case, $12 is larger than my selling price. So I know that if I proceeded with the production, I would start losing money. So my profit would become negative. So in that case, I would stop the production. So marginal costs are used in order to give the company an idea on when to stop the production. So as long as the marginal costs give you or yield back a cost of an extra unit still smaller than the selling price of that unit, the company could still keep on the production going. However, if the marginal cost starts yielding back a value or a cost of production of that extra unit larger than the selling price, then the company would decide to then stop the production. However, what do the derivatives have to do with that here? So if I were to represent this quickly using this graph. So over here, for x equals to 0, now these are the fixed costs of production for x equals to 0, so that's way before I started my production. However, if I had produced x units, so I know that that is C of x. And then if I want to study as the cost of producing an extra unit, so that would in fact be C of x plus 1. So you'd notice here if I were to change color, so usually the derivative at x would be represented by the slope of the tangent. So the slope here is C prime of x. However, going back to the marginal cost, you'd notice that the marginal cost is the difference between Cx plus 1 and C of x. The denominator here is 1, and the difference between x plus 1 and x is 1. So I could replace the denominator by x plus 1 minus x. Now, graphically, that would be the rate of change between these points on the curve. Now, since over here, the increment is just happening by 1 unit, the increment is small. So in that case, you'd notice graphically that that rate of change, that segment here formed by joining these 2 points where the slope is given by this rate of change, is almost parallel to the tangent at x. So being almost parallel, it means that c prime of x, which is the slope of the tangent, is approximately equals to c of m. So the marginal cost could be approximated by the derivative at that point. So for that reason, in order to study the marginal cost, what we do is in fact study the derivative function of the total cost. So now, having highlighted the difference between the different cost functions, it would be in fact similar if we were to study a total revenue, a marginal revenue, and an average revenue, similarly to the profit. So over here, if I were to look quickly at this exercise in order to put everything we've explained into perspective. So a company uses the function c of x equals to this cubic polynomial to estimate the cost in euros of producing x items. Now, the revenue of selling X items is modeled by this. Now, the revenue would be the amount of money that you are selling your products for. The cost is how much you're paying to produce them. The revenue is determined by the selling price of these items, while the profit is the difference between them. So I need to first start by finding the cost of producing 300 items. So since c of x is the cost of producing x items, then the cost of producing 300 items would be c of 300. So replacing x by 300 would give you back 1,120 euros. However, I need to find the marginal cost of producing 300 items. So the marginal cost, as we've seen, could be determined by calculating c of 301 minus c of 300, or by finding the derivative at 300, according to what we've just explained. However, the derivative is more widely used anyway. So over here, in order to determine the marginal cost, I need to first start by finding the derivative. So differentiating that cubic polynomial would give me 1 minus 0.02 x plus 0.00018 x squared. If you're not sure how I did the derivative, it's good to revisit the lesson on derivative functions. So now c prime of 300, replacing x by 300 in the derivative function would give me 11.2 euros. So the cost of producing an extra item more than the 300 I've already produced would cost me 11.2 euros. Now, it's very important to highlight that the marginal cost really depends on where you lie on the function. So perhaps if I were to be dealing with a function that is increasing rapidly as x goes to positive infinity, then the marginal cost here would be smaller than the marginal cost there. So this is what we've spoken about knowing when to stop the production. However, for part C, we need to find the marginal profit of selling 300 items. Now, we know that the profit is in fact the revenue minus the cost. So it's how much I sold minus how much it cost me to produce them. That would be the profit of the company. Now, the marginal profit is still the derivative of the profit function, so which is the marginal revenue minus the marginal cost. So over here, I need the marginal profit when 300 items are produced. So that is R prime of 300 minus C prime of 300. Substitution would give the marginal profit.